Today we're going to test our knowledge with gas laws, understanding Boyles, Charles, and hopefully we can get to some other gas laws. So let's go ahead and get started. First question deals with Boyles law, and whenever we're trying to answer these Boyles law questions or any gas law question, we need to one understand the formula involved, and we also need to understand pressure conversions because they're an invaluable tool. One other standard of reference I would include, just because I tend to care about it, is you want to make sure that you're aware of the conversion between milliliters to liters. If you're ever put in a situation where it gives it to you in milliliters, and sometimes that will occur, you want to know that 1,000 milliliters is indeed equal to 1 liter. So for Boyle's law, the unique thing about it is, in general, as long as your pressure units and your volume units are consistent, you can answer the questions as is. Although, as a standard of preference, I tend to lean towards putting my units of pressure in ATMs, and I tend to put my unit of volume in liters. Now, for Boyle's law, you need to understand that it expresses an inverse relationship. And what that inverse relationship means is that as the pressure increases from P1 to P2, the volume will decrease. So that's what an inverse, or I guess I would call it indirect, it depends on how you look at it. When I talk about relationships, it's more of an inverse. One goes up, the other goes down. So when you're looking at that graph, you want to make sure you can explore that relationship when you are comparing P to V, where if the pressure is going down, this volume is going to increase. So make sure you understand that. Alright, so let's get started. We start with, if 22.5 liters of nitrogen at 748 millimeters mercury are compressed to 725 millimeters mercury at constant temperature, what is the new volume? Now remember, constant temperature is definitely a giveaway or a telltale when you're dealing with Boyle's law, because usually you're comparing pressure and volume solely if you have constant temperature. Sometimes questions might trick you and say that, it gives you a certain temperature and it doesn't give you another temperature listing. You could assume that that temperature maintains the status quo. So we can assume here that we have 22.5 liters, and that can constitute our V1. And we know that 748 millimeters of mercury is a pressure measurement, and we can assume that to be our P1. Now our P2 in this question is actually given, and that is 725, and we are questioning or trying to determine the value of V2. Now, as I mentioned, when dealing with Boyle's law based questions, it doesn't matter if the units are in ATM, millimeters of mercury, or anything thereof. However, as a standard of preference, I tend to lean towards putting my units in ATMs. And to achieve that, especially going from millimeters of mercury to any unit, you just divide simply by 760, as 760 millimeters of mercury is equal to 1 ATM. So, setting this up, initially, I say 748 millimeters of mercury times the V1, which in this case is 22.5 liters, is equal to my P2, which is 725 millimeters of mercury, and my V2, which is my unknown. I'm then going to proceed to divide each of those by 760, the pressure units, because that's going to convert these guys to ATMs. So dividing those converts those to ATMs. And when I divide 740 by 760, I'm sorry, I get roughly 0.984. So, .984, my unit is ATM. I'm still going to end up multiplying that by the 22.5 liters. And I'm going to go ahead and proceed to divide this 725 to convert that to ATMs. Divide that by 760. That yields 0.954 ATMs. And my V2 is still unknown. Now, I'm then going to proceed to divide both sides by the 0.954 here. And that's going to eliminate this pressure being on the right-hand side of the equation. And I'm going to divide that on this side because you want to kind of apply kind of an identity function here. Alright, so those check out. That leaves me with V2. And V2 is going to be equal to whatever the product is of this equation. In which, to solve it, I just simply take 0.984, multiply that by 22.5, and I'm going to divide that by 0.954. And that's going to give me approximately 23.2. And that's going to be in liters. Now, what should be noticed is if you compare the values of P1 to P2 and V1 to V2. P1 has a value of 748, and that value decreases to 725. And because there's an indirect relationship, this is going to imply that going from V1, which is 22.5, we should expect this value of V2 to increase. That value does increase. We didn't know prior to actually solving the problem by how much it increases, but we should know that because of the inverse relationship, this number does increase. Okay, so let's look at another one. Let's go ahead and look at number 2 here. I'm going to fold my paper to make some room. Oh, folding it too much there. Alright, so for question number 2, we're still dealing with Boyles' law. And this question states, a gas with a volume of 4 liters at a pressure of 205 kilopascals is allowed to expand to a volume of 12 liters. What is the pressure in the container if the temperature remains constant? Remember, temperature remains constant, or they don't give you another value and they're not asking you to solve for it, then you're dealing with this pressure and volume based question, which is going to likely imply a Boyles law like problem. So we don't have our conversion like we generally did before up there up top, but I can tell you that the conversion unit for kPAs is going to be 101.3, and we're going to use that to convert this guy to ATMs, and then we can go about solving it as we've done before. So let's go ahead and get ready to look at that. And to do that, we're going to assume that our P1 value in this case is 205 kPa. Our V1 is 4 liters. We don't have our P2 value, and then our V2 value is actually 12 liters. Now, as I highlighted before in question number 1, there is an inverse relationship. This is going to imply that comparing V1 to V2, we notice an increase in the volume in liters. This is going to imply that the P2 value is in fact going to decrease. Now, to solve this question, all we're going to do is we're going to simply plug in the values. That's our P1. 4 liters is our V1. Our P2 remains unknown at the moment, and our V2 is 12 liters. So then we're going to go ahead and solve. We can actually keep this guy in kPa because the answer we're going to get is going to be in kPa. If we wanted to, we could actually convert this to ATMs. For consistency's sake, I can go ahead and express how that would look in ATMs. 101.3 kPa is what you divide that by to convert it to ATMs. That yields 2.02 ATMs. And then we are going to multiply that times our 4 liters, and everything else checks out as the same. P2, we don't know, 12 liters. I'm trying to solve for. Divide both sides by 12 liters. That cancels out. And when we step forward in solving it, we yield a value of 0.673 ATMs is equal to P2. Now, if we wanted to solve this using KPA, we would also be able to obtain the answer. We wouldn't necessarily have to divide by this value. Simply put, 205 times 4 divided by the 12. It's going to give us a value of 68.3 kPa. And that is very similar. In fact, if you wanted to compare that, you would simply just divide this value by 101.3 to get what the conversion is in ATMs. So either of these would be fine, depending on what the question was asking for. If it wanted the pressure in kPa, you could express it using that. If you wanted an ATM, you can express it using that. They're very similar. So that completes our instructions on Boyle's law. I'd like to get ready to proceed to our next part, which is going to definitely deal with Charles' law.